All right, here we go. So what we have here are confidence intervals. These are little, they look like little dots with arms, right? These are how we depict confidence intervals. And what this is showing you is 25 samples. If I reset it, here's 25 samples and 25 intervals that have been calculated. The green line down the middle represents the true mean that we're trying to predict here, okay? Notice that all of my intervals hit that green line at some point, right? So they're good intervals. They give us a good, solid prediction of the truth. Now, I was shooting for 95% accuracy. And in this case, 100% of them hit it. Do you see the 100% down there? Okay. Do you think it's always going to be 100%? No, because of sampling
Guys, you're going to have to get more work done.
Sampling,
I can't let you sit there.
Oh, look, there's one interval there that missed, didn't it? I do another,
Charger.
2 missed, but I'm still at 96%, so I haven't gone below the 95% confidence. Go again, 96, 96, 97. So if I say I'm 95% confident, what that's telling me, oops, that one went lower, didn't it? That if I take many samples and calculate many 95% confidence intervals, 95% of them will hit the truth. Does that make sense? 95% of the intervals that are created will capture the true value. Will they all? No. But 95% of them will. That's all we're saying here, okay? So that's the idea of a confidence level, because you're going to have to interpret a confidence interval, which is what we just did. We are 95% confident that blah, 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 blah. Then you'll interpret the level, which is a little wordy, but this is the idea, is that if we do a bunch of samples, calculate a bunch of intervals, only a certain percent will capture the real value. All right? That's the idea. It's funny. All right, sorry about that. Now, the other thing is we have two things we can mess with here, a confidence level and a sample size. You see the sliders here? So I want you to see what these two things affect and how they affect an interval. Now, which one do you want to mess with first?
Interval.
The level?
Oh, yeah.
The level? Okay, confidence level. So here's how I think about confidence level. Think about it as the size of your target. If I have a really big target, what happens to your confidence when I ask you how confident you are you're going to hit it? If it's really big. It's high, right? But if I make that target small, your confidence decreases, right? Because what's our target? It's the parameter. Okay, so if I'm at 95% confidence here, what do you suppose is going to happen if I take that slider and I reduce my confidence? What's going to happen to the length of my interval? You think it's smaller? Let's see. So if I take this guy, slide him down. See it? See how smaller it got? So then, conversely, if I take it up all the way up to 99%, it gets wider, doesn't it?
So, what you're saying is if we have confidence, we'll make it.
The bigger it is, the higher our confidence, right? Yeah. That's what confidence interval does. So we're talking about the width of our interval. Now, let's put it back at 95. Let's see if I can get it to 95. Oh, there it is. Okay. Now let's play around with sample size. What have we said so far in this course about sample size? If we increase our sample size, what happens? Say it again? The more accurate our estimate is, right? How will that help us when we do confidence intervals?
You won't need to have as big face paddles.
We won't need as much margin of error, right? These arms are like our margin of error. We won't need as much, will we, if we're accurate? So let's predict this. If I take my sample size, it's 30 right now. If I raise it up to 200, what do you suppose is going to happen to our little arms? Shrink in? Let's just see. Look at that. Hardly any margin of error because we don't need it. We're pretty spot on, right? So then conversely, if I take that sample size and take it way down, what's going to happen here? Ginormous, because we have to account for a lot of error, don't we? Now, one thing I want to point out is that even if I increase my sample size, or decrease my sample size, that does not change the bias in the question. You remember how we talked about bias and the way the questions are worded and all the business? Margin of error does not account for that. That's just built into the problem. You can't account for it by having a bigger margin of error. That's one thing that I like to say to you. All right. So let's switch gears and go back to our simulation. Now, if we look at this and we decide to whittle this down to what is it we need to know. Okay, first thing you need to know is how to interpret a confidence level. Remember, the wording is different than a confidence interval. In the last lesson, when we did confidence interval, it talked about our sentence was like, we are 95% confident that the interval from A to B captures the true proportion of whatever. This is level. So it looks like this. This is if we take many, many samples and calculate a confidence interval for each, about 95% of them will capture the true parameter. So C is our confidence level that we're looking for. Then we looked at that applet with the sliders, and we talked about margin of error. And we said this. We said that if our confidence level goes up, our margin of error goes up because our target got bigger, which means the only thing changing there is margin of error. Now, in terms of our intervals, we would say we would get a wider interval. If the sample size goes up, we said our margin of error goes down. So we would say we have a narrower interval. Now, the third thing you need to take away from this is realizing that the margin of error does account for sampling variability. The thing that we know that all the samples are going to be a little different. We know that, but it does not account for bias, okay? It does not account for any kind of bias, like response bias, undercoverage, non-response. None of that is accounted for when it comes to a margin of error. So let's look at this application problem. You can try it on your own and come back and check it with the key. If you'd like to pause the video, feel free to do that. PE teacher of a large high school wants to estimate the mean number of push-ups students the school can do in 1 minute. He selects a random sample of 30 students from those who are there after school for sports practices. He records how many push-ups from each student in the sample can do in 1 minute. He determines that he is 90% confident that the interval from 24.1 to 28.5 captures the mean number of push-ups students at the school can do in a minute. Now it says interpret the confidence level. So I'm going to use my sentence structure up here and say if we take many, many samples and calculate a confidence interval for each, about 90% of them will capture the true, in this case, what is it? Mean number of push-ups students at this school can do in 1 minute. All right. Then it says, explain what would happen to the length of the interval if the confidence interval level was increased. So it's increasing our target, which means margin of error gets larger, which makes it wider. It would get wider because the margin of error increases. How would a 90% confidence interval based on a sample of 200 compared to the original 90%? So the original, remember, was 30 students up here. So we're going way higher in our sample size. So we said up here, if our sample size increases, our margin of error goes down, which creates a narrower interval. So we would say it would be narrower because a larger sample size decreases margin of error. And then D, describe one potential source of bias in the study that's not accounted for by the margin of error. Well, looking at the way they collected the data, look at this. What does it say he does? He selects a sample of 30 students from those who are there after school for sports practices. So he's only selecting from athletes for practices. So anyone who goes to the school that's not in athletics is not part of this data, right? So that means that there's an undercoverage bias. So there's undercoverage because students not in after school sports practice are not represented. All right, so that's the last part of 8.1 is kind of giving us the concept of confidence level, and it also helps us see the relationship between the margin of error and confidence level and sample size. And then it makes the point that that margin of error accounts for variability only, but not bias.